All right, today we're going to talk about complex numbers. All right, so the imaginary unit I. The imaginary unit I is defined as I equals the square root of -1, where I squared equals -1. So what this says is anytime you get an I squared, you can replace it with a -1. So we have complex numbers and we have imaginary numbers. The set of all numbers in the form a plus bi with a real number a and b and I, the imaginary unit, is called the set of complex numbers. The real number a is called the real part and the real number b is called the imaginary part of the complex number a plus bi. If b does not equal 0, then the complex number is called an imaginary number. An imaginary number in the form bi is called a pure imaginary number. Okay, so here's some examples of complex numbers. Here's -4 plus 6i. The real part, or a, is -4, and b would be 6, which is the imaginary part. For 2i, this one would be a pure imaginary number because it doesn't even have a real part. The real part is 0. And the imaginary part would be 2. Here, this one doesn't have an imaginary number. It is going to be, if you can rewrite 3 as a complex number, you can write it as 3 plus 0i, which would make 3 the real part and the imaginary part 0. The equality of complex numbers says that if you're claiming that two complex numbers are equal, then A has to equal C and B has to equal D. Okay? Alright, so when you're adding and subtracting complex numbers, you add the real to the real and the I to the I. Same with subtraction. Okay, they do this with, they do factoring and watch. It's more sense this way. All you got to do is just act like I's are variables when you're adding and subtracting. And until you multiply and divide, I is just like X. So if this was 5 minus 11x plus 7 plus 4x, what I would do is I would distribute that positive, and I get 5 minus 11i plus 7 plus 4i, and then combine like terms. 5 plus 7 is 12. Negative 11i plus 4i is negative 7i, and I'm done. Subtraction, you just got to be careful because whatever you're subtracting, every term that you're subtracting is going to have to change signs. This is going to be -5 plus I plus 11 plus 6i because I distribute the negative and multiplied a negative by a negative and a negative by a negative. So now if I combine like terms, -5 plus 11 is 6, 1i plus 6i is 7i. And that would be my answer. Okay, you try one, hit pause, come back when it's ready. When you're ready. And hopefully you got 8 plus 2i. So nothing crawls here. I've got 6 minus 4i. Distribute the positive, changes nothing. Combine like terms. 6 plus 2 is 8. Negative 4i plus 6i is positive 2i. Try this one. Hit pause. Come back when you're ready. And hopefully you got 6 plus 11i. Alright, parentheses first, so I'm distributing the two negatives. So I'm going to get -6 plus 5 plus 4i plus 7 plus 7i. Combine like terms, I have -6 plus 5 is -1 plus 7 is positive 6. Positive 4i, positive 7i is positive 11i. Alright, so how do you identify the real part of a complex number? The real and complex part of a complex number. A is the real, B is the imaginary. How do you add and subtract complex numbers? Combine, like, well, you know what? I should say parentheses first, then combine like terms. Okay? Did I skip one? Yeah. Alright, to multiply complex numbers, you're distributing. I mean, you can call it FOIL if you have two binomials, but if they aren't both binomials, it's just distributing. And remember that anywhere you see I times I, you get I squared, which turns into a real -1. So when you multiply, again, you're just distributing. But in multiplication, the only thing you have to worry about is if you end up with an I squared. Anytime you end up with an I squared, you have to change it to a real -1. So 4i times 3 would be 12i. 4i times -5i would be -20i squared. But that I squared can be rewritten as -1. So now distribute, I get 12i plus 20. This is not wrong, but it's considered rude. You want to answer, a complex number is always the real plus the imaginary, not the imaginary plus the real. I mean, it's not wrong, it is just commutative, but it's just considered rude. You're supposed to write your real term first. So my answer would be 20 plus my imaginary term would be 12i. That would be improper. Okay? All right, for B, we've got two binomials, so both of them have to multiply. So 7 is going to go first. 7 times -2 is -14. 7 times -5i is -35i. And then -3i goes, times -2 is +6i, and -3i times -5i is +15i squared. So now we did parentheses, it's just a matter of combining like terms. I can combine my i's and replace my I squared. So I have -14, -29i plus 15 times -1. That gives me -14 minus 29i minus 15. Combine like terms, I get -29 minus 29i. And I'm done. Okay, you try one, hit pause, come back when you're ready. And hopefully you got 2. So if I distribute my -3i times +5i is -15i squared, and -3i times -4 is +12. My I squared, or 12i, sorry, my I squared turns into a real -1, which gives me 15 plus 12i. And it's in the right form, so I'm good. All right, try this one, hit pause, come back when you're ready. And hopefully you got 1. So I do -6 times -6 is +36. -6 times -i is +6i. Positive I times -6 is -6i, and positive I times -i is -i squared. When I go to combine like terms and change I squared, my i's actually cancel out, and I get 36 minus a -1, which gives me 36 plus 1, which gives me 37. Wait a minute. Where'd my I go? Well, it canceled out. And if you look at these, see how the first term is the same as the first term, the last term is the same as the last term, the only difference is the sign in between them? These are what we call conjugates. And when you multiply a complex number by its conjugate, you eliminate the i's, which we need to do in certain circumstances. All right, so how do you multiply binomial complex numbers? You distribute. You sub -1 for I squareds, and then you combine like terms. Okay? Alright, so the conjugate of a complex number. I just kind of cheated and showed you ahead of time. The complex conjugate of the number a plus bi is a minus bi. Like I said, all you do is change the sign in the middle. If this is positive, the first term is positive, keep a positive. If it's negative, you keep it negative. The only sign that changes is the sign in the middle. So the complex conjugate of a minus bi would be a plus bi. And the multiplication of complex conjugates gives a real number because the I terms will always cancel out, okay? And if you're dividing complex numbers, you can't. You can't divide by I. It's not real. So what you do is, what they're saying is, like, let's say that I gave you 4 over 3 plus 2i. You can't do that division. Okay, that doesn't work. But you can't leave your answer like that because some guy said, for whatever reason, oh, we can't have complex numbers in denominators. So again, we're going to have to rationalize the denominator. And the way we do that is we're going to multiply the numerator and the denominator by the conjugate of the denominator and then simplify. And as long as there's no more I in the denominator, it's good. Alright, so here we go. It says divide and express the result in standard form. You can't do that division. So what you do to make that dude that made up this rule happy is say, alright, I can't divide, but I can't leave an I in the denominator. So I'm going to multiply the top and the bottom by the conjugate of the bottom. Because we just saw that when you multiply conjugates, the I disappears. The conjugate of 2 minus 5i is going to be 2 plus 5i. And now you're just right back to multiplying. It's just you got to do 2 problems. Once on top, once on bottom, and then simplify. On top, I have 7 times 2 is 14. 7 times 5i is positive 35i. And positive 4i times 2 is positive 8i. Positive 4i times positive 5i is positive 20i squared. If I combine like terms and replace my I squared, I have 14 plus 35 and 8 is 43i plus 20 times negative 1. That gives me 14 plus 43i minus 20, which gives me negative 6 plus 43i. There's my top, negative 6 plus 43i. My bottom is going to be 2 times 2 is 4. 2 times positive 5i is positive 10i. Negative 5i times 2 is negative 10i. Negative 5i times positive 5i is negative 25i squared. Those are conjugates, so boom, boom, those are always going to cancel out. You'll get to the point where when you see conjugates, you'll just skip writing those two. You'll just do the first and the last and skip outer and inner, because these, if they're conjugates, these will always cancel each other out. So that leaves me with 4 minus 25 times a negative 1, which gives me 4 plus 25, which gives me 29. So my answer is negative 6 plus 43i all over 29. And it is rationalized. Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 3. I can't divide by I, so I'm going to multiply the top and the bottom by the conjugate of the bottom, which is going to be 4 plus I. On top, you're going to have 28i plus 7i squared. Simplify that. The only thing I can do is replace that I squared with negative 1, which gives me negative 7 plus 28i. There's my top. On bottom, I have 4 times 4 is 16. These are conjugates, so look, 4i, negative 4i cancels out, and that's going to be negative I squared. So that's 16 minus a negative 1, which is 16 plus 1, which is 17. And that's it. But why do they do this? I don't know, because they like to irritate us. They just split it, and they said that's negative 7 divided by 17 plus 28 divided by 17. Alright, this is not wrong. This is perfectly acceptable. But I do believe Math Excel even makes you put it in like that. Alright, try this one, hit pause, come back when you're ready. And hopefully you got 1. Alright, so I have 7 plus 4i over 5 plus 8i. I can't divide, but I got to rationalize, so I'm going to multiply the top and the bottom by the conjugate of the bottom, which is going to be 5 minus 8i. Alright, so on top, I have 7 times 5 is 35. 7 times negative 8i is negative 56i. 4i times 5 is positive 20i. 4i times negative 8i is negative 32i squared. If I simplify this, I have 35 minus 36i minus 32 times negative 1. So I get 35 minus 36i plus 32, and that gives me 67 minus 36i on top. On bottom, I have 5 times 5 is 25. Negative 40i, positive 40i are going to cancel. Like I said, you'll eventually get to the point where you just stop doing that step, which is fine. Don't do it until you're comfortable, but that's fine. Positive 8i times negative 8i is negative 64i squared. So that gives me 25 minus 64 times a negative 1, which gives me 25 plus 64, which gives me 89. So my denominator is 89. There's my solution, but again, they split it. 67 over 89 minus 36 over 89. Okay? So how do you multiply complex conjugates? So we already answered that. You distribute. What happens when you multiply a complex number by its complex conjugate? You get a real number. No more i's. How do you divide by a complex number? You don't. You multiply the top and the bottom by the conjugate of the bottom. Alright, so now we're talking about principal square roots. Remember before how we told you that if you had the square root of negative 16, you had to say that it's not real. Well, it's still not going to be real, but now that we understand I represents the square root of negative 1, we can actually just say that this is going to be, because this would be the square root of negative 1 times the square root of b. Well, the square root of negative 1 by law is negative 1, is I. So that becomes I times the square root of b. So, for example, if I've got a negative square root of 32, that's the square root of negative 1 times the square root of 32. This is I, and if I break down 32, by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2, and I can look for bundles of 2. So that's the square root of 4, which is 2. That's the square root of 4, which is 2. And he has to stay in. So that's going to be times 4 square roots of 2. Now, to write it properly, you do 4i square roots of 2. You also might see 4 square roots of 2i at the back. I don't like writing it like that because sometimes it looks like my I is underneath that radical, and it's not. So I like to write mine in front, but they might make you write it like that. I'm not sure. Alright, the square root of negative 81, that's the square root of negative 1 times the square root of 81. That's I. That's 9. So my answer would be 9i. Okay, the square root of negative 2550, that's the square root of negative 1 times the square root of 2550. If I break down 2550, by 5 is 510. By 5 is 102. By 2 is 51. By 3 is 17. So all I have is a bundle of 5s. So I'm going to have I times 5 times the square root of those 3 left, which, use a calculator or just back up, it's going to be the square root of 102. So I'd have 5i square roots of 102. Yeah? Alright, you try one, hit pause, come back when you're ready. And hopefully you got 5i square roots of 6. This is going to be the square root of -1 times the square root of 150. That's I. And I got to break 150 down. By 5 is 30. By 5 is 6. By 2 is 3. I got a bundle of 5s. That makes a 5. And these guys back in. So this is times 5 times the square root of 6. So I have 5i square roots of 6. Alright, try this one. Hit pause. Come back when you're ready. And you should get 14i. This is going to be the square root of -1 times the square root of 196. Break down 196. By 2 is 98. By 2 again is 49. By 7 is 7. So I have a pair of 2's, which makes the square root of 4, which is 2. I got the square root of 2, a pair of 7's, which makes the square root of 49, which is 7. So this becomes I times, this becomes 2 times 7, which gives me 14i. Okay, so proficiently work with powers of I. That's what we were doing. Alright, so when you multiply radicals, you multiply the coefficients of the radicals and multiply the radicands, and then simplify. Adding and subtracting, you have to have matching radicals in order to add and subtract. In other words, the indexes must match and the radicands must match. If they don't, you can't combine them. And then multiplying binomial radicals, still you just distribute and combine like terms. Alright, so we've got a negative square root of 18, or square root of -18 minus the square root of -8. I can't add and subtract those because these don't match, and I can't do anything until I get rid of the negatives. So this is going to be, again, I'm going to write this one more time. This would be the square root of -1 times the square root of 18 minus the square root of -1 times the square root of 8. But again, I don't even write that anymore. I just know that that's going to be I square roots of 18 minus I square roots of 8. The negative comes out as an I. Now I can work on simplifying these, just like we did before. You can't add them until they match. So if I break down 18, by 2 is 9, by 3 is 3. That's the square root of 9, which is 3. So this is I times 3 times the square root of 2. If I break down 8, by 2 is 4, by 2 is 2. 2 2's makes the square root of 4, which is 2, and he's back in. So this is minus I times 2 times the square root of 2, which gives me 3i square roots of 2 minus 2i square roots of 2, which is just 1i square root of 2. Alright, we got -1 plus a -5 squared, the square root of -5 squared. Okay. Biggest mistake people make here is they just square this and think they're done. And every time you do that, a puppy dies somewhere in the world. Whenever you square a binomial without making 2 copies, if you don't want to kill puppies, you've got to make 2 copies and FOIL it out. And I'm going to get that I out right now. So that's going to be I square roots of 5 times -1 plus I square roots of 5. Squaring it means you multiply it by itself. But if you don't write it out, you'll only do two of the multiplications, and your answer is going to be wrong. So now I have -1 times -1 is +1. -1 times a positive I square root of 5 is negative I square roots of 5. Second one goes, I square roots of 5 times -1 is negative I square roots of 5. I square roots of 5 times I square roots of 5 is I squared square roots of 5 squared. So now I can clean up combine like terms and clean this mess up. I'm going to have 1 minus 2i square roots of 5 plus -1 times 5, because the square root of 5 squared is going to be 5. So I have 1 minus 2i square roots of 5 minus 5. Combine like terms, I get -4 minus 2i square roots of 5. Okay? Alright, if we look at this one, I'm going to get that negative out first. So I have negative 25 plus I square roots of 50 over 15. Now I can break down 50 by 2 is 25, by 5 is 5. That's the square root of 25, which is 5, and he's back in. So I have negative 25 plus 5 times I times the square root of 2 all over 15. That gives me negative 25 plus 5i square root of 2. I just wrote that again. And now the only thing I can do, don't touch the underneath, just like I told you before. Don't try and reduce with the radicand, even if you can, which I can't, but even if you could, don't. Don't touch him. He's protected. You can't get to him. But these outside numbers are all divisible by 5. So that would give me negative 5 plus I square roots of 2 over 3. Okay? You try one, hit pause, come back when you're ready. Hopefully you got 48i. Alright, I'm getting the negatives out, so that's going to be 5i square roots of 64 plus 4i square roots of 4. Then I'm going to break them down. Well, I know the square root of 64 is 8, and I know the square root of 4 is 2. So that gives me 40i plus 8i, which gives me 48i. Excuse me. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got negative 55 minus 48i. Alright, so if we're going to square this without killing puppies, it's going to be I square roots of 64 squared. I got the negative out. If that radical can be simplified now, I'm all for it. So the square root of 64 is 8. So that's negative 3 plus 8i squared would be negative 3 plus 8i twice. Sorry. That's going to be positive 9. That's going to be negative 24i. That's going to be negative 24i. And that's going to be positive 64i squared. So if I combine like terms and replace my I squared, I get 9 minus 48i plus 64 times negative 1. Sorry again. Tried to walk away, but it's not so loud. So that's going to be 9 minus 48i minus 64. Combine like terms, I get negative 55 minus 48i. Okay. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got 2. Alright, so I'm going to rewrite this. Negative 12 minus I square roots of 72 all over 6. I'm going to break down that 72. By 2 is 36. By 2 is 18. By 2 is 9. By 3 is 3. Square root, I'm looking for bundles of 2. Square root of 4 is 2. Square root of 9 is 3. That one's in. So this becomes negative 12 minus 2 times 3 times I times square root of 2. All over 6. That's going to be negative 12 minus 6i square roots of 2 all over 6. I can divide them all by 6. And that gives me negative 2 minus I square roots of 2 over 1, which is just negative 2 minus I square roots of 2. Just a second to go cough my head off. Not in your ear. Alright, sorry about that. Alright, so we've been working with the powers of I. Alright, so if we try these, this is just some homework help on things you might run across. Again, first thing I'm going to do here is get that negative out. So this is going to be negative 3 minus I square roots of 7 squared. To do this without killing puppies, you have to make 2 copies. Negative 3 times negative 3 is positive 9. Negative 3 times negative I square roots of 2 is going to be positive 3I square roots of 2. Negative I square roots of 2 times negative 3 is going to be positive 3I square roots of 2. Negative I squared of 2 times negative I squared of 2 is going to be a positive I squared square root of 2 squared. Okay, so now if we clean this mess up, that's 9. That's going to be 6I square roots of 2. That's going to be a negative 1 times 2, because the square root of 2 squared is 2. So that gives me 9 plus 6I square roots of 2 minus 2. Combine like terms, I get 7 plus 6I square roots of 2. Okay, over here I have negative 6 minus I square roots of 12 over 48. Break down 12. By 2 is 6. By 2 is 3. Square root of 4 is 2. So I have negative 6 minus 2I square roots of 3 over 48. Well, I can reduce my outies by 2. That's going to be negative 3 minus I square roots of 3 all over 24. Okay. Yeah. All right, so here, get your negatives out. So this is going to be 3I square roots of 5. This is going to be negative 4I square roots of 12. Multiply your coefficients. That's negative 12I squared. Square root of 5 times 12 is 60. So this is going to be negative 12 times negative 1. I'm going to break down 60. By 2 is 30. By 2 is 15. By 3 is 5. Square root of 4 is 2. So this is going to be times 2 square roots of 15. And that's going to give me positive 24 square roots of 15. All right, I can't add these unless I can make them match or they're perfect. So get the negatives out. That's going to be 5I square roots of 16 plus 3I square roots of 81. That's going to be 5I times 4. That's going to be 3I times 9. That's going to be 20I. That's going to be 27I. Oops. Which is going to be 47I. Dang it. Okay. All right, so this one says evaluate x squared minus 2x plus 2 for x equals 1 plus I. They're telling you to replace x with 1 plus I. So I have x squared minus 2x plus 2, and I'm replacing x with 1 plus I. To do this one without killing puppies, I have to make 2 copies. Here I can just distribute. That's negative 2 minus 2I and drop the plus 2. So I need to multiply before I combine like terms. Although I can. This negative 2 and this positive 2 are going to be out. 1 times 1 is 1. 1 times I is I. I times 1 is I. I times I is I squared. Minus 2I comes down. Combine like terms and clean up your I squared. So this is going to be 1 plus 2I plus a negative 1 minus 2I. And I get, wow, 1 minus 1 cancels and 2I minus, so you get 0. If I replace that with 1 plus I get 0. Okay, so this one says evaluate for x equals 3I. So I have x squared plus 19 over 2 minus blank. Plug in my 3I. On top, that's going to be 9I squared plus 19. That's going to be 9 times negative 1 plus 19. That's going to be negative 9 plus 19, which is going to be 10. So there's my top. On bottom, I'm going to have 2 minus 3I. So I did the substitution, and I got 10 over 2 minus 3i. And I'm not wrong, that's a perfectly correct answer, but I'm not allowed to leave behind the denominator, so I have to rationalize the denominator, which means I'm multiplying the top and the bottom by the conjugate of the bottom. Conjugate of 2 minus 3i is going to be 2 plus 3i. So on top, if I distribute the 10, I'm going to get 20 plus 30i. On bottom, 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. And negative 3i times positive 3i is negative 9i squared. Combine like terms and clean up your I squared. Those cancel because we're conjugates. And it's 4 minus 9 times a negative 1, which is 4 plus 9, which is 13. And that would be my answer. But remember, Math Excel probably wants you to write it like that. Oops. Okay? And then you got a little word problem here. It says complex numbers are used in electronics to describe the current in an electric circuit. Holmes' law relates the current in a circuit I in amperes, the voltage of the circuit E in volts, and the resistance of the circuit R in ohms. By the formula E equals IR. Use this formula to solve exercise 55. So my formula is E equals IR. And they're saying find E, the voltage of the circuit, if I is 4 minus 5i amperes, and R is 3 plus 7i ohms. Well, you're multiplying. So 4 times 3 is 12. 4 times 7i is 28i. Negative 5i times 3 is negative 15i. Negative 5i times 7i is negative 35i squared. Combine your i's and clean up your I squared. I get 12 plus 13i minus 35 times negative 1. That gives me 12 plus 13i plus 35, which gives me 47 plus 13i. That would be my voltage. Alright, so we are at homework, which means we are done. Happy homeworking, and I will see you next time.